Good evening, my YouTube viewers. Crystal here. What I wanted to do this evening was I wanted to give you a solution to Analytic Bidhida's customer segmentation competition question. I got about a 64% on the question, which was pretty good considering the fact that I was reading the discussion, and even on the discussion somebody was complaining because he said he cleaned up all the data and did as much as he could, and he could only get like a low 60 percentage as well. And the reason why is because the data that we're given to work with isn't very good, and that's why we don't get a very high score. There were a few people who scored like in the 95 percentile, and I'm not sure exactly what they did, but I'm in the middle of taking an Analytics Bidhida course on how to win a competition, which is a series of videos made on people who have won competitions in the past. So after I watched the videos and found out their secrets, maybe I can win a competition, because I really could use some good news. I could use victory in my life. The first thing I'm going to do is let you know that I'm on GitHub. So the repository is on GitHub under customer segmentation. So you can always look me up and you can always look on the code. It's not winning code, but it's good code. So, and it'll get you on the leaderboard. So with this competition question, the first thing I did was I imported a lot of libraries, and you'll see that when I was working on this competition question, I had a lot of experimentation, and so a lot of the libraries that I opened were a result of that experimentation, as you can. The next thing I did was I read my files. So my 3 files are on GitHub. So if you want to use the files, feel free. At least you won't have to load them onto your computer and use up your computer's memory if you don't want to. The next thing that I did was I assigned scalars, but I ended up not using any scalars. The only thing that I used was label encoder, because I was trying to get the best score, the best accuracy possible, and I found out that I would get the best accuracy by not having any scalars at all. And I only use label encoder. I'd use one hot encoder. So you can see the train file here. You see there's lots of strings in the train file, and the computer doesn't want that. The computer wants everything to be converted to a number, and then once everything is converted to a number, then the computer will work with it. So that's one thing that we needed to do. Another thing, if you look at the info on the train file, you'll see we've got lots of objects and 2 floats. Well, the computer really wants to be working with integers. So we have to convert the objects to integers, and we have to convert the floats to integers as well. Test file is the same as the train file, except for the fact that on the test file you don't get a segmentation column, because your segmentation column is your target. Test info is the same as the train info, except that there's no segmentation column. The next thing we did was we put some code in to check to see if there were any null values. And so here's the code here on the train file and the test file. And then what we did was we replaced these codes. What I had originally done was I had originally filled everything in with mode or median. And then as I was experimenting, trying to get the best value, I took out mode and I put yes in forever married, because I noticed that there were more married people than non-married people. So I put yes there. I put cat 6 in for var 1, because I noticed that cat 6 had the highest value of people. I put healthcare for profession, because when I plugged in artist, my score went down. And so I tried the next highest level, which was healthcare, and it brought my score up a little bit. I put in no for graduated because that brought my score up, that brought my accuracy up. So we had to fill in median values. I kept work experience at median, and the reason why is because in the end I decided not to use work experience in the features, and the reason for that is because I was reading the discussion and it said that the work experience didn't tally up with the age. And I thought, well, if the work experience doesn't tally up with the age, there's not really much point using it. And I think that's another thing that needs to be kept in mind. Whenever we get a data set, we need to look and see if the other columns adequately correspond with each other. And if they don't adequately correspond with each other, you might get a better score if you leave that column out. And so I experimented with leaving columns out, but the only column that I was able to increase my score was leaving out work experience. And because the work experience column was so dubious, it wasn't going to really bring that much to the computer program anyway. On family size, I decided to make it a family size of 4 because with a family size of 2, I didn't get an increase, and on a family size of 3, I didn't get an increase. But on a family size of 4, I did get an increase in the accuracy. The next thing we did was we removed unnecessary characters. Now, that's how I removed the unnecessary characters, but another way that it could have been done was to just put it on label encoder. But I didn't know very much about label encoder at the time, which is why I used this. But in the future, I'll just be using label encoder if I need to. Or, it's okay to take the cat out. Perhaps to take the cat out would be better because then the number wouldn't start with 0, because when you use label encoder, the first number starts with 0. So if you don't want the first number to start with 0, maybe it would be better just to take the string out. So I also had some columns that I wanted to convert to integer because that's what the computer wants to see. It wants to see integers. So I converted work experience, family size, and var1 to integers, even though I ended up not using work experience. And the last thing we did was we did a test to see if there were any null values after I replaced all the null characters. And no, there were no null values after I replaced all the null characters. So what we did now is we did a group by on segmentation to see how many we had of each variable. And then what I did was I used the label encoder to label encode the segmentation because the computer doesn't want to see A, B, C, D and wants to see, 0, 1, 2, 3 in this instance. And next thing I did was I did a chart on the Y value, and you can see the Y value. And they were pretty much similar variation, a distribution of values. And so I decided not to use the smote, and I think I even tried to use the smote, and it just ended up making my value worse, making my accuracy worse. So on the segmentation, we did a group by on the segmentation, so you can see now it's numbers. It's 0, 1, 2, 3 instead of A, B, C, D. We did a chart on age versus work experience, and it just turned out to be all blue. But since the age doesn't correspond with the work experience anyway, I just decided to delete the work experience column. So we did a group by on sex, and you see that there were more male shoppers than female shoppers, and we have a chart that confirms that, and we put the sex under the label encoder. And so now we did another group by of the married, and you see that there were more married people than non-married people. So we did a chart on that, and that confirms that there were more married people than non-married people. And we put married under label encoder as well. And we also just did a little group by to see that, yes, there were more married people than non-married people. We checked the age, and we plotted the age with a violin plot, and you can see most people were around 40. We plotted the ages on another chart, and you can see that the highest age range was 26 to 35, but 36 to 45 was just slightly lower. We checked to see if the customers were graduates, and you can see that there were more graduates than non-graduates, and we've got a chart that shows there were more graduates than non-graduates. And so we put graduated under a label encoder, so you can see here that you have a 0 and 1 value. We checked their profession, and you can see the artist was the highest profession, which I was quite surprised about, and healthcare was the second highest profession. We had to put the profession under the label encoder, and now we have a new profession, and you can see that it's all put in, just giving numeric data. We put work experience on a violin chart, and you can see that most of the work experience was about 1 year, which did not correspond with people's ages. So that's why we decided not to use work experience in the features. Sorry about that. I know that this speaker picks up my voice a lot too, a lot better than my other computer. And then what we did was we checked the spending score, which was average, low, and high. And so we found out that the highest percentage of the spending score was low, and then average, and then high. We put low, average, and high under a label encoder, and we renamed the columns. We checked the family size, and the family size was all the way up to 9 people. And we did a violin chart on the family size, and you can see that the largest family size was 2 people. We checked var1, which was an anonymized variable, and you can see that the largest value was number 6, I believe. And we put that on a chart, and that confirms that the largest value was number 6. So after we did all that data pre-processing, we can look at our train file again, and you can see now it's all digits. The test file is the same. The test file is all digits as well. And if you look at the info, you see it's all integers in the train file and the test file. And that's what we want, because that's what the computer program wants to work with. And then what we did was a heat map of the segmentation, so you can see how the features correspond with the segmentation. So now what we've done is we have to set up our features. So the features is gender, age, ever married, graduated, profession, spending score, family size, and var1. And your target variable is train labels, which is segmentation reshaped. So what we have to do is we have to prepare the data. So Y equals train labels, that's your target data. X equals PD get dummies, train features, and that's your features right up here. And X test is PD get dummies test features. So the features were assigned to both the train file and the test file. So now what we do is we split our training file into X train, X validation, Y train, Y validation using train test split. We use X and Y to do that, and we have a test size of 15%. And you can see that I didn't use the scalar because the scalar made my reading worse. So we decided we were going to use the random forest classifier. So we set up the random forest classifier, we fit it, and then we predicted on it. And then we tested our accuracy, which was 47 and 48. Now what we do is we want to get the parameters and find out what's going on. So if you know what the parameters are, then you can go through and change them. And I can see, let's see if there's anything. I mean, if you wanted to change the parameters, you could, and that might actually increase your score just a little bit. The next thing we checked was your F1 score and F and recall score. That was a 48 and 47. So then we created a confusion matrix on this. And then we also created another matrix to see how many predictions they made on each target variable. We wanted to check the accuracy, so you've got a precision matrix and had an accuracy of 47. And I think that's a lot to do with the fact that the data we were working with wasn't very good. YPRED equals RFC predict X validation. And so we checked our accuracy, which was 47.81%. Y validation equals Y validation flatten. So what we did was we flattened the array of Y validation in PRED so we could put it on a data frame so you can see what the actual value was and what the prediction was. The next thing we do is predictions equals RFC dot predict X test, and X test is the features in your training set features. And predictions equals predictions as type int, because you want it to be an integer, because that's what the computer wants to see. And we looked at predictions. And one of the last things that we had to do was we had to inverse transform the label encoder, because we had previously encoded the label of segmentation. So we have to reverse that, because that's what Analytics VidHaya wanted to see. They wanted to see A, B, C, D. So we output the ID from the test set and the predictions onto a data frame and called them ID and segmentation. We output this to a CSV file, and we print a little message that says your submission was successfully saved. And then we upload this submission onto my submission.csv. And then what we did was we loaded it into the download file, and we uploaded it into Analytics VidHaya Solution Checker, and I got a close to 64% accuracy, which was what somebody else was complaining. Then I was reading the notes, and somebody else was complaining that said he cleaned his data and he did everything he was supposed to do. He could still only get about a 60% accuracy, which is what I found. And so that just means that the data that we have to work with isn't very good or isn't very reliable. And definitely work experience wasn't very reliable. But that's, we can only predict on what we have to work with. So that concludes this solution, If you like my solution, please like, subscribe, and share. If you like the work I do and you want to support me, then I've got my email address to my PayPal account in the description. And the reason why is I don't have enough subscribers, so the only way I can get monetized is to ask for donations. And thank you so much for watching my video and looking at my solution. And I look forward to making other videos for you.